Hello, everybody. So this is section 16, literal equations. And in this section, we're going to cover exactly how to solve these literal equations. But, before we begin, here's the definition that we want to use for literal equations. So it's an equation that has at least two or more variables. So normally when we have an equation and we need to solve it, we have an equation in terms of a single variable, and when we solve it at the end, for example, assuming that the equation has just one variable x, our answer is going to be x equals a number. Now, in literal equations, that doesn't happen because we have maybe multiple variables. So when we solve the equation, the answer is just not going to be a number. It's going to be an expression in terms of other variables. So we might have, for example, x equals 2y plus z over 5w, for example. So this is what we called a literal equation. So it's an equation that is solved for one variable in terms of other variables. Now, the process that we use to solve this obviously varies depending on the equation that we have to solve. But for the purposes of this course, these literal equations are going to be somewhat similar to solving rational equations. So I've enumerated some of the steps that may be necessary to solve them. So for example, if we have a denominator, we're going to factor all denominators. In that case, we're going to find the LCD of the denominators. We're going to then multiply every term by the LCD. We're going to solve the remaining equation, and then we're going to get an answer in terms of the other variables. Now, obviously, if the equation does not have a denominator, this becomes a lot simpler, but still applicable in our cases. So, for example, let's take a look at 16.4. We'll begin with this one first. The equation is P times Q times R equals 5, and we're asked to solve for P. Now, what does that mean? It means that at the end, I must have P equals, and on this side, anything else but no P. So if we're solving for a variable, that variable has to appear, for example, on the left side, and on the right side, I cannot have an occurrence of that variable. Okay? So for example, let's solve this first one. In this case, obviously, I do not have a denominator, so I don't need to factor anything. But since I am solving for P, which is this variable here, all I have to do is have P equals something else on the other side. Now notice that in this equation, I have P times Q times R equals 5. All I have to do is somehow get rid of the Q and the R in this equation. Now this is very much similar to, for example, if I had 3P equals 5. All I would have to do is divide by 3. Well, in this case, it's the same thing. All I have to do is divide by QR. And if you do it on the left side, do it on the right. Now, the QR on the left cancel with the QR that I've divided. I'm left with P equals 5 over QR. Now, at this point, we check to see if we have an answer. I am solving for P. P is isolated on the left, and there is no occurrence of P on the other side. So this is my final answer for that problem. So this is how you solve a literal equation. It's a simple one, but this is how we solve it. All right, let's take a look at the second example, 16.3. Notice that I have an equation again, no denominators, which is okay. I am asked to solve for y, which means after I do all my algebra, I am going to have y on the left side and on the right, whatever else, but no y variable. Okay? So here is the term where I see the y. So anything that is not y cannot be on the left side because I'm solving for it, right? I have to have y equals. So I'm going to get rid of the 2x, the positive, so minus 2x. And if I do it on the left, I do on the right. And I'm going to get rid of the positive 5. So this is what I have to do, right? Here, they will cancel. I am left with 3y. The positive and negative 5 would cancel. And I'm going to have 8x minus 2x. And I'm going to have negative 16 minus 5. Now, at that point, because I'm solving for y, I have to get rid of the 3 that is multiplying the y. Now, don't get confused that you think you have to add something here or subtract 3, right? We don't. We have to divide. And the reason we have to divide by 3 is because the 3 is multiplying the variable you're trying to solve for. So you have to divide by 3 here. You have to divide by 3 here. And you have to divide by 3 there. Okay, these two will cancel as expected. And I have y equals. And then you simplify or divide 6 by 3, get 2x, and negative 21 over 3, 7. Now, we check to see if this is our final answer. I am solving for y, so y is isolated on the left. And on the right, I do not have the y variable. So this is it. This is my final answer. Now, let me give you a word of caution right here. At this point, sometimes a student will do this. Divide 3 here and divide 3 there. Right? They correctly cancel the 3 on the left side, but then on the right, they just do this. And they write the final answer as that. Notice that this is not the same as my answer. The reason this thing here is incorrect is because the 3 is also dividing the 6. So it is best that you do what I did over here, okay, on the left side. Make sure that when you're dividing, you divide each term on the right so that you do not make a mistake. So this is another literal equation, very simple, no denominators yet, that we solve for one particular variable. Now let's see another example. Okay, let's see these two cases. We're going to take a look at 16.5 first, where we're going to solve for t. Now, because we're solving for t, at the end, I have to have t equals and something on the other side that does not contain a t. So here's the term with the t. So the first thing I do is get rid of the s on the left side because I have to isolate t on the left. So minus s here, and obviously minus s on the right. On the left, they cancel. I'm left with RT equals 15 minus S. And now because I'm solving by T, I have to get rid of the R by dividing both sides by R. And again, do it this way. In this case, it does not matter because the R doesn't cancel with anything on the numerator. But I'm going to be left with T equals 15 over R minus S over R. Now, in this case, this is fine. You could write it this way, or if you prefer, obviously, you could do 15 minus S over R. Both cases, the answer is fine. Okay. Also, a simple linear equation with no denominators for us to factor. Now, 16.6, we're going to solve for h, but we have parentheses. So the very first thing that we have to do is we have to get rid of the parentheses by distributing g. So g times 1, g times h equals k. And now because we're solving for h, anything that is not h has to go to the other side. And we begin by removing this g. Okay, so subtract g on both sides. Notice that this is subtraction because this is like, for example, if I had something like this, gh equals k, and to get rid of this positive 5, we just subtract on both sides. So this is exactly the same thing. So in here, the g's will cancel. I'm left with gh equals k minus g. And now I'm back to something we recognized before. I'm solving for h. The g is multiplying my h, so I have to divide by h. And notice, do each separately, okay? On the left side, the g's will cancel. K over g cannot be reduced, but g over g becomes 1. Now, again, do not do the following, which is a common mistake. Students will do this and they'll get, k minus 1, which is incorrect. Notice the answer we have right here. Okay, so divide each one separately. All right. Next set of examples are probably a little bit more involved. So let's first do 1611. Again, we're solving for h. And now my h is in the denominator. So this qualifies as a rational equation, but it's rational and literal at the same time because we have multiple variables. Now the technique is factor. Nothing to factor here. H plus k is already completely fully factored in the sense that it cannot be factored further. We find the LCD, which happens to be h plus k. We multiply both sides by the LCD, just like as we did with rational equations. And the purpose of that is to get rid of the denominator or denominators. So on the left side, the h plus k will cancel with this. I'm going to be left with 2 equals m h plus k. And now at this point, this becomes similar to that example we saw just a couple minutes ago. We're solving for h, which means that because of the parentheses, m has to be distributed here and there. mh plus mk. Now I obviously can do this, right, to make sure that I have my variables on the left. So if 2 equals mh plus k, mk, then mh plus mk is equal to 2. And then I can work with this side of the equation. Now I am solving for h, this variable. Anything that is not h has to go to the other side. So the very first thing I observe is this term doesn't have an h. So to get rid of it on the left, I subtract mk. And if you do it on the left, you do it on the right. So they cancel here. I'm left with mh equals 2 minus mk. And now, because I'm solving for h and I have to isolate h on the left side, and m is multiplying my h, we just divide by m here, and here, and there. On the left side, the m's will cancel. This first fraction cannot be simplified. And the second fraction, it can. gonna have k minus k, or k over 1 is fine. Okay, so here is my answer for that problem. So this is more like a rational equation type where we needed to find the LCD. No, it wasn't necessary to factor anything, but multiply or multiplication by the LCD was useful. Like the last equation, and I'm going to erase this because we're going to need the space, I think. The last equation we need to solve is this one right here, which is an important case where it looks very simple. We're solving for y. Now notice I have two terms where I have y. Now, because I'm solving for y, that means that at the end I have to have y equals, and on the right side, no y. So to solve this, I must have all of the terms with y, with the variable I'm solving for, on the same side. So I want this cy on the other side. So I'm going to subtract cy from here. And if I do it here, I do it over there. Let me just erase this part. So now I have a x by minus cy equals 0. And because I'm solving for y, anything that is not y cannot be here. So I'm going to subtract both sides by ax. They cancel here. I have by minus cy equals minus ax. Now, this is an important situation. Students usually get confused because they don't know how to proceed. I need to solve for y, which means that I have to have a solution that says y equals something, which means I have to have only a single y as my final answer. If you have multiple terms with the variable you're solving for, you must factor it. So you're going to factor y, and you're going to get b minus c equals a minus ax. At this point, I have y times something else, just like if I had 3y equals minus ax. All I have to do is divide by 3. So in this case, the thing that's multiplying my y is b minus c, so I'm going to divide by b minus c. If I do it on the left, I do it on the right. All I have to do now is cancel b minus c here, and my final answer will be y equals minus ax b minus c. Okay? So this is an important problem because it may happen that I may have an equation where I have two or more occurrences of the variable I'm solving for. And if that happens, you always must factor that variable at the end in order to get an answer. Okay, so this is how you solve literal equations.